Hello folks, today we're going to demystify coin problems and I'll discuss how to solve all kinds of common coin problems given a set of coins and a target value. In particular, we're looking at A, finding the number of ways we can get change, B, finding the maximum number of coins that we can get change, and then C, finding the minimum number of coins to create that change. Stay tuned.
Let's say that you're in a convenience store and you had in your pocket 3 20 cents, 5 10 cents, 2 5 cents, and 5 cents. And you wanted to buy a pack of gum that cost 100 cents. Well, today we're going to answer how many ways you can combine those coin types to get that pack of gum. And we're also going to find out, given all those possible combinations, which combination has the least number of coins and which combination has the most number of coins needed to get that target value. So I'm going to discuss some other solutions too to these problems in another video, but before I did, I want to discuss how these problems that we have here are actually related and how in solving one of them, you can solve all of them at the same time. Let's start off by defining the input. So we'll let C equal the coin types. For our problem, we have the coin types of 20, 10, 5, and 1 cent. And then we'll let Q represent the quantity. And for this, we have 3, 5, 2, and 5. Also, we have T, and T is our target. That will be 100 cents. And then we have group. So this is one that I did not discuss before, but it's very important. So group is what we're using to store our temporary coins that we have selected. And I'm going to get into that more later on, but we do need to define it. So we'll define group as an empty list in this case. All right, so let's define what this function is going to look like. So I call this the mother coin function. So we'll have, it's going to take C for coins, Q for quantity, T for the target value, and then we'll just put group here. And as mentioned before, we'll initialize this as an empty list. So let's discuss this from a really high level, because again, I want to make sure that you guys understand this from the more fundamental aspect, and then that way you can expand on that if needed be. So step one. Step one is to store a copy of the group. As I mentioned before, the group is important because we are storing the current coins that we've selected between trials, and we need to keep track of the original. So having the group defined here will allow us to revert back to the original. Step two is to outer loop through each coin. What's important to mention here is that as we're looping through the coins in this outer loop, there are two circumstances in which we want to skip coins. The first circumstance would be if that coin is too large. So for example, here our target is 100. Let's suppose that we had a coin that was like 200, right? If we had a coin that was 200, it wouldn't make sense to consider that coin because no matter what number we added 200 to, it's always going to be more than 100, right? So there's no way we can get 100 as a target. So automatically we want to skip coins which are too large. So skip coins larger than T. All right. In a similar fashion, we want to skip coins if you don't have any coins. I know it sounds very obvious, but we have to code this somehow, right? So, for example, let's say that we have 20 cents and the quantity that we have is 0. Let's say that in our pocket, we know that 20 cents, yes, it does exist, but we just don't have any. That would be 0. If that's the case, then we don't consider that with any of our trials and we skip it. So skip coins that have a quantity of 0. Another important aspect of the outer loop, which is looping through each coin, is that we have to define decomposition. So I haven't gotten there yet, but step 4 is going to use recursion. And what happens is whenever we choose a coin, we want to eliminate that as a possibility. And in order to do that, we're going to create 2 variables here that will hold on to that information. So I'm going to create a variable and we can call this, let's call it C. So C is for coin. So C without ith coin. And then we'll define another one. We'll call this Q without ith quantity. So I know at this point, some of you may be like, wait, why do we have this? What's the purpose? The whole purpose is this, and I'm going to get into this later, but like, let's say that you have, originally we have coins of 20, 10, 5, and 1. Again, we're using recursion here, so we have to do decomposition, which makes the problem simpler and simpler. So within the inner loop, which we'll get to in just a moment, we're going to consider the possibility of this problem in which we don't have the 20-cent coin. And then in a similar fashion, we want to take the quantity list and then we want to eliminate that as well. So our problem becomes simpler and then we're only considering these as the coins and also as the quantity that we have. So that's essentially why we have to define that here. Step 3 is to inner loop through each quantity for that particular coin. So again, this is an inner loop. So this loop is within this outer loop here. Outer loop again is for coins, and then inner loop is for the quantities for that coin. So inner loop through quantity. And I'll give an example. So when we're looking at the 20 cents, if you recall the 20 cents, we have 3 coins in our pocket. So the first loop that we'll have, we're going to be looking at what happens if we have 1 20 cent. So if we select 1 20 cent, what does this problem decompose to? And then in the second loop, we're looking at if we select 2 20 cents, what does this problem decompose to? And then in the third loop, we're looking at if we have 3 20 cents, what does this problem decompose to? So that's really what's happening every single time. So step 4 is where we have the magic happening. So step 4, within, so this is actually happening within the inner loop. So within inner loop, right? Within the inner loop, we want to do recursion to test for other coins. All right, so again, we're testing for other coins within the inner loop, and we're testing those possibilities. So that's what we're doing here. And how does that work? So essentially what's happening is we're calling the same function again. We're calling the mother coin function. And instead of passing in Q, remember we're doing that decomposition. So again, we want to reduce that list of coins that are being considered, and then we want to reduce the list of quantities that are being considered. So we're not passing in Q and C, we're passing in the C, which is C, so the coins without the ith coin. And then we're passing in Q without the ith Q. And then the target, we're not passing in the target. We also decompose the target as well, because think about it this way. If you pick a coin, that means that you can actually reduce the target. So if we chose 1 20-cent, we would reduce the target by 20 cents and we'll pass in 80 cents. So here I'm going to represent that by this target. And then also we'll pass in the group. So the group would be whatever we have selected as the coins as of that moment. And I've already defined these two. I'm circling these so you can see it. I've already defined these two variables. Let me define this target. So this target is equal to whatever the original target was. Then you have to minus the coin. So we'll call the C at I, which is whatever coin we selected. Whatever coin we're omitted from here, we are going to minus that. And then we times by the coin that we're selected. So remember, we're looping through the quantity. So we'll call this quantity. If you recall, if we're looking at the 20 cents, this quantity would go from 1 all the way to 3. So this is going to be changing every single time. So that's important. And the group, what we will do here is we'll do group is equal to group dot extend. And this is very Pythonic language. Again, I'm not really, trying to get too caught up with the language. What's important here is that whatever coins you have selected, you want to pass that into your function again. So here I would represent that as whatever we have for this quantity, and then times a list of coins. So for example, if during this loop, this inner loop, if we're looking at 2, I would do 2 times, and let's say that we had 20 cents. I would do 2 times 20 cents, which would be equivalent to having 20 cents and 20 cents. And that's what we'd pass in. So that's essentially it for using the recursion. Now, what's important here is when we find out what we have passed in for the group, we then have to reset it. So here we'll do group is equal to the original group. And again, this is very Pythonic language. If you're looking at Go or Ruby or whatever, you write this differently. In fact, it wouldn't be group is equal to group. You would have, for Python, you would have group is equal to whatever the start group was, right? So this essentially says reset the group to whatever you have before. Now you may be asking why. The reason why you want to reset the group is because here in step 4, you're looping through each of the quantities. So let's say in quantity 1, we choose, or let's say quantity 2, we choose 2 of the 20-cent coins. So we have that, right? The next time we come around, we then want to maybe choose 3. So we do 3 times the 20-cent coins, and then that's what we would insert into this recursion. And therefore, we want to always reset this so the next quantity loop would have a fresh start group. So that's essentially why you do that resetting there. And that's essentially it. So these are the high-level steps that you would do in order to calculate the value. One thing that I forgot to mention is how would you know when to stop? Or more importantly, how would you know when to save that particular group? So you would save a group once the target is equal to 0. So as you're looping through here, once you're in the middle loop, or not middle loop, but once you're in the inner loop, which is for quantity, if you ever have a circumstance in which your t is equal to 0, then save group. So you want to hold on to that group. So that means that all of the coins in this group were able to add up, and when you do the this target, which is equal to the original target minus this, you get 0. That means that these coins here will add up to give you the target. So that's what it means. So essentially, that's where that would occur. And again, you can code this in different ways, but it's important that you know where that happens. As far as more details, I have the code included here. I have the code in Go and also in Python. And then if you want to see more information about the various steps, you can visit my blog. I do go into a little bit more detail and have an example as well. Thank you very much.